travel must be swift. It must be comfortable. But above all, it must be safe. Your motoring safety begins long before you take to the road. When you choose your Austin, you are choosing safety. You look for smart appearance and generous equipment. You expect easy handling and alert performance. Economy is also highly desirable, but you demand, you must have safety. This vital quality of motoring safety begins when your car is being designed and built. Expert craftsmanship backed by science makes your motoring safe. At Longbridge, safety is assembled into your car. Keeping well within the white line, nothing is left to chance. Good brakes are a vital safety factor. A final check of the brakes on your car assures safety. This system of mechanical braking is unequal for enduring efficiency, a quality derived from a correct manufacture of all the vital parts, so that they conform precisely to a highly efficient design. An important requirement is a braking surface both smooth and true, verified by carefully checking the accurately ground surface of the cast-iron drum. Safety also depends upon the friction linings, which must be so woven and bonded as to withstand the stress and heat of braking, and give at 10,000 miles all the stopping power provided at 10. Intricate machinery and accurate recording instruments are used to ensure these qualities. This test is continued under uniform conditions of load for over a week, equivalent to 20,000 miles of normal service. Any change in the coefficient of friction of the Checo brake lining under test, the degree of wear, and the heat generated by the friction are visibly verified, and so in an emergency you can stop in time and with safety. The same unvarying efficiency is required of the steering gear, for safety dictates easy and accurate directional control. There must be positive response to your movements of the wheel. The worm and sector must give easy movement from lock to lock. That is why these components are verified so carefully with special measuring instruments. The center point of the worm and its diameter at that point, namely where the worm and sector mesh for straight ahead steering, must be verified to 1,000th part of an inch. The feeler used for this purpose is itself most carefully checked from time to time by optical means. Placed in the path of a parallel beam of intense light, its profile is projected onto a table. Enlarged in this way up to 50 times full size, the vital outline can be verified by direct comparison with the master drawing. By this means, the presence of the minutest discrepancy would be immediately obvious. Easy steering equally depends on the front wheels running true and obeying the steering mechanism. This is a question of angles which are carefully measured. The inspector checks every vital axle dimension before assembling, and the angle of the holes for the swivel axle pins, which determine the position of the road wheels, is verified with special care. The accuracy of the gauge itself is checked by optical means. Placed on a glass table, light is projected past the baseline of the gauge into the ocular. Then, by moving the table to bring the inclined face under the ocular, its precise angle can be checked. This delicate instrument, which can split the circle into minutes, each at 21,600th part of a full circle, will immediately detect any error if such exists. At Longbridge, they keep well within the limits of safety. But the best braking would be ineffective if the wheel studs failed, and the most accurate steering of no avail should the steering arm fracture. Adequate strength to resist the heaviest impact is vital, and to verify this, a elaborate plant is necessary. The tensile or stretching test is most frequently employed. The special alloy steel used for the wheel studs and steering arm should withstand a pull of 45 tons to the square inch. The indicator shows that the test piece, a quarter-inch square in cross-sectional area, proves true to specification. A further test directly records the resistance to impact. The extent to which the notched test piece impedes the swing of the heavily weighted arm indicates its strength. Is the alloy correct? The steloscope provides the answer by analyzing light emitted from an electric arc struck between the metal under test and an iron electrode. This light is split up, and the bands of color seen through the eyepiece indicate in this instance the presence of molybdenum, and so reveal exceptional strength. At every stage, safety is assured. The white line is never crossed. Today, not only the body itself, but the windows and windscreen are safe. Prince Rupert, adventurous nephew of King Charles I, discovered the secret of this safety. The glass will withstand hammer blows if suddenly chilled by being dropped into water while molten, although shattering into harmless fragments when the end is nipped off. From this discovery has been developed the tempering process responsible for the remarkable safety qualities of the glass in your car. Here is the production test with Triplex toughened glass. Every piece is passed under the hammer before being approved for use. Under this ordeal, ordinary plate glass that has not been toughened puts up a sorry show. A steel ball of just over 1.5 pounds in weight provides the standard laboratory test for toughened glass. Dropped from a height of up to 12 feet, it makes no impression on the glass of your windscreen. There is no suspicion of damage, no sign of fracture. From nearly 12 feet, the ball is going. But the glass has not gone. Ordinary untoughened glass fails under the impact from only 15 inches drop. Because it can deflect through 15 degrees each way without breaking, a Triplex toughened windscreen will carry a load of 2.5 hundredweights while supported only at each end. Polarized light passed through specimens of ordinary plate glass and toughened glass reveal the secret of this strength. Whereas in the plate glass there is one broad line of stress, in toughened glass there are many. These merge to act like a tough outer skin which stretches yet holds the glass together. But if this outer skin is pierced, it fractures into harmless fragments that are splinter-free and will not cut, and the road is still visible ahead. It is more difficult to demonstrate effectively the stability of the modern car and the strength of its all-steel body. We do not suppose you will wish to emulate the test we now depict, but watch how this Austin 10, although running along a slope of nearly 45 degrees, positively refuses to roll until it reaches the projecting rocks. Then over it goes, over and over and over before coming to rest. This Austin body has suffered only superficial damage. The windows and doors will operate. Most of the windows are intact, but those which have broken have shattered into harmless, splinter-free fragments. There is no vital distortion of the main structure, no dangerous crushing. It is strength such as this that makes motoring safe. The modern motorist can be confident of his car. For speed on the road, for climbing, for cornering, for stopping, because he gets so much more safety in an Austin.